So hey everyone, want to learn how to build a great web application? Well, stay tuned. Next up is Herbert Bintoroe from OVO. Mr. Bintoroe graduated from the University of Wisconsin-Madison with a bachelor's in computer science and finance. Prior to working with OVO, he worked in Silicon Valley for over 7 years as an engineering manager for Eventbrite. Today, he'll be giving a workshop on Architecture 101. Please give a warm welcome to Herbert Bintoroe. Sir, the floor is yours.
All right. Hey, let me try to make sure that everybody can see my screen. Hello? Hey, all right. Okay. I would like to thank everybody, especially the Garuda Hacks team for inviting me to speak on this event. A lot of good content already on the past day, and looking forward for more great content. Thank you for everyone who's attending this talk as well. So today I will be talking a bit about web architecture. It's not as comprehensive, it's not as hands-on, it's more of like a story of how web architecture usually evolves. And yeah, that's the topic of my talks for today. Here. So yeah, the agenda for today's presentation, I will talk a bit about myself, and then I will also take probably 5 to 10 minutes to talk to you guys about OVO. And then we will enter into the main content, which is about web architecture. And I will also tell you guys about the guiding principles of choosing the right architecture for you. And I will have probably 15 minutes in the end if you guys have any questions. But this is very casual, so in case you guys have any questions in the middle of my talk, just feel free to chat it, and I can answer either during or after the talk. Alrighty. So about me, as introduced earlier, I got my bachelor degree from University of Wisconsin-Madison in 2010. I double major in computer science and finance. After graduating, I got my first job as a software engineer in Branch Technologies. I spent 1.5 years there. This company is based in San Mateo, California, and this is an SEO platform technology company. After Branch Technologies, I joined Eventbrite. This is probably where I spent most of my career at. I spent 7.5 years at Eventbrite. Most of you might know this already. Eventbrite is based in San Francisco, California. I grew from software engineer, and the last role that I had before leaving Eventbrite was an engineering manager. And I came back for good to Indonesia in March 2020. So I've been back home in Indonesia for the past 5 months. I joined OVO as an engineering manager. As you might know already, OVO is based in Jakarta, Indonesia. So a little bit about OVO. Hopefully most of you have this installed in your phone already, but OVO is one of the biggest financial tech company in Indonesia. OVO is the leading digital financial services company in Indonesia. Probably most of you know OVO as just an e-money provider, but it actually offers a wide range of services from lending, insurance, investment, and some other stuff. OVO is accepted nationwide, and we're committed to building the largest financial technology company in Indonesia. We are actually #1 payment platform in Indonesia by transaction volume. Sorry. So OVO is founded in 2017 with the vision of becoming Indonesia's largest non-bank digital financial services with an open ecosystem of partners and holistic financial products. And we aim to fulfill this vision by providing equal opportunity through financial access, by building reliable and convenient financial solutions to empower SMEs and improve the lives of all individuals in Indonesia. As you can see, Indonesia has a very unique geographical landscape. But I think one thing that is very, very exciting for us is that our GDP is projected to set 5.5 trillions in 2030. And this is a massive opportunity for the whole Indonesian market. As you can see here, in terms of internet penetration, for example, at 2019, we are at 32%, and it's expected to reach 54% in 2023. And the same way, in terms of the percentage of GDP that comes from e-commerce, at 2019, we are at 1.4%, but at 2023, it is expected to have 3%, right? So the opportunity is massive here in terms of growth and how OVO can help in this market. So this slide talks about how Indonesian MSMEs, micro, small, and medium enterprise, contribute to 57% of GDP and 97% of employment. However, there's a gap here where they have a lack of access to finance, right? And this is also where OVO can come in and help Indonesian people. So the biggest problem for any country for government dispersal is how to make sure that we actually disperse money in a very efficient manner. And how do we make sure that the budget is received by the right citizens? And OVO is partnering with government to help with that, to help solve that problem. So, government have some budget that they want to disperse to Indonesian people, and now we are helping them to be able to do this more efficiently. Some of partnerships that has happened in the past, right? We had this Kartu Prakerja initiative. This is basically catered for people who graduated from university but hasn't had the chance to work yet. And then we also help with the disbursements of Kartu Sembako. So yeah, this is something that we are OVO is doing with the government as well. And another interesting fact here, in terms of fintech market, compared to China, Indonesia still have 3 times growth to be harnessed across digital financial services segment. So if you look at the penetration rate, for example, Indonesia now still have only 6% penetration compared to 33% of China. In terms of underbanked population, Indonesia have around 50%, right? Like half of the people in Indonesia doesn't have access to bank. Whereas in China, now that number has decreased by a lot. Now in China, the number of underbanked population is less than 5%. In terms of also digitalization, right? The number of transactions that happens through cash in Indonesia is still 60%, but in China, it's now less than 20% of transaction or payments are happening through cash. And the same way in the financial services market as well, we still have a lot of room to improve. For example, access to credit. 70% of Indonesian people don't have access to credit compared to 38%, less than 37.5% in China. But I guess my point here is that we still have a lot of room to grow in terms of financial technology in Indonesia. So in the past 3 years, OVO has grown like no other, especially against the very hyper-competitive market and a very dynamic payments landscape. And we believe that these 3 operating principles have guided us towards success. The first one is building an open ecosystem. So it's the success that the position that OVO is in right now is not the result of only our hard work, but also with partnerships with other people, with our organization. We found that this strategy of having open ecosystem have propel our business in the past few years. We work very closely with Grab and Tokopedia. In the earlier slide, we also work with Indonesian government. And this partnership has equipped us with the tools and expertise to scale quickly and reach a very large user base effectively. The second one is on leveraging technology and data. Technology enabled us to do things more effectively and more swiftly. while data is the key for us to understand our customers' behavior and how we can create value to our customers and our partners. And both technology and data, we believe, will drive our goal to realize financial inclusion in Indonesia. And lastly, about stimulating growth through positive disruption, OVO as a company is committed to delivering services that address all the gaps in Indonesia's financial ecosystem. So in this slide, I'm going to talk a bit about how OVO's open ecosystem has lent itself to become the #1 digital payment service with the most use cases. So we have a lot of verticals that we take part of. Some big parts here, like in terms of online merchant, we are partners with Tokopedia. Tokopedia is the #1 e-commerce in Indonesia. For transport, we partner with Grab, right, which is the #1 ride-hailing provider also. In terms of offline merchants, we have a large network of offline merchants. We actually have the largest offline acceptance network in Indonesia. In the financial services market, we partner with Prudential for insurance, and we partner with Barexa for investment. For food, we also partner with Grab Food. But on top of all of these things that we partner with, we also have other products, right? Such as utility billing, groceries, parking, telecom, and all this other stuff that we have. So technology and data are OVO's key unique value proposition for both customers and partners. OVO deploys one of the largest IT systems in Indonesia to serve millions of customers and hundreds of thousands of merchants. We serve billions of transactions, and we invested in building a full solution ranging from eKYC, payment, financial, risk, and APIs for our seamless partner integration. All these billions of transactions data are generated and stored in our data lake. And using big data technology, we use machine learning and AI as well. We are able to detect customer behavior patterns, which allow us to predict the needs of our customers before they happen. We use these insights and models to better serve our customers, prevent frauds, and as well creating new assets like the OVO score that hopefully can help us drive financial inclusion in Indonesia. Yeah, also through innovation, OVO strives to create positive impact in the market as well as in the community. The screenshot here on the left is OVO initiative in partnering with local artists in OVO Collaborasi. And as I mentioned earlier, we also partner with government to disperse money for Kartu Prakerja. And looking forward, I believe that to be able to sustain this growth, this is for operating models that OVO is adopting right now. And the first one is about sustainable growth, right? And how do we make sure that when we are launching a new product, we're able to work very effectively to make sure that it's cost efficient and we get the highest ROI possible. The second one is about vertical focus. We try to adopt a tribe model where when there's a new project, we can form a tribe very quickly, where this tribe will be able to drive this project to completion, and we can disband it or reform it if needed. The thirdly is about people transformation. Having a flexible and agile working environment have allowed us to make immediate changes when necessary. A good example that happened recently is us in implementing the work from home policy to anticipate COVID. And lastly, it's about tech excellence. We established tech centers outside of Indonesia. Now we have a tech hub in Singapore as well as Bangalore. And we also developed a very world-class fraud and risk systems that we are pretty proud of. So that's it in terms of OVO's introduction. If you guys have any question, please feel free, or I can take them at the end of this session as well. Now, entering into the main topic of of this talk is about evolution of web architecture. And I will go about this talk by just telling a story, right? Like how a startup builds an e-commerce website. So let's imagine that we are a team of 2 or 3 people, a very small company, and our goal is to build an e-commerce website. So let's say we want to build an e-commerce website when we sell stationery, right? So in this website, you can sell books, pens, bags, and whatnot. So I work with a couple people, and this is the initial idea that we came up with. So let's imagine that we can have a homepage that looks something like this. Just a very simple page with the list of items that you can buy and a checkout page. So when you click on an item, for example, if you click on a book here, you will be redirected to the /checkout URL. And in this URL, you'll be able to see the description of the book, the price of the book, and then you can select how many books you want to buy, and you can click buy. A very, very simple. In this story, I'm oversimplifying a lot of things. And let's say these 2 pages are good enough for us to launch. So building homepage and the checkout page. So if you might imagine, this is probably how your system will look like in a very high level. So you have 2 URLs, and /home and /checkout. And each one, both of them will talk to the server. And in the server, it will talk to database as well. But as you can see, in the blue box here, the home page is responsible for any logic related to listing products. In the checkout page, because now we can see the product details as well as buying the item itself, the checkout page is responsible for logic related to product display as well as payment. And let's say 2 weeks gone by and we actually got traction. We got business, and we want to add new functionality to our website. Research has shown that having a search page has been proven to be very effective in a lot of e-commerce strategy. And at the same time, this is the number one pain point that a lot of customers are asking us this feature. And hey, I want to add the search functionality because now you have so many products in your website, and I need a way to be able to search what I'm looking for. So let's imagine that we come up with this idea of creating this new search page. So in this, we have a new page which will be hosted in /search. Now here you can enter the keyword. For example, you can enter books, and now you can only see book items. So how do we go about building this? Building this would be probably something like this. So as you can see, the home and checkout page doesn't change because we're just building a new search page. And the bulk of this logic for this search functionality is how do we make sure the search functionality works. And probably we don't want to build a different way of listing our product because we've already built it in the home page. And because we need to get this done very, very, very quickly, we just basically copy pasted the product list logic from our home page to our search page. So it might look like this, right? After adding the search page to our website. So now, after a couple of weeks, the search page is performing really well. But we got a feedback where your search page is well, but why are we not showing it in the homepage? The traffic to the search page is pretty low because it's very hard to find. So we got an idea to actually just add a search bar to our homepage. So if you remember from earlier, our website initially just lists the list of items, but now you can see that there's a search bar here where you can enter your keyword to do search functionality. And how do we go about doing this? Right, being a startup that we are and trying to move very quickly, this is probably what's going to happen. You're probably just going to copy paste the search code from our search page to our homepage, and everything else looks the same, right? It's just the only difference here is that we add the search logic inside our homepage, and everything else stays the same. So let's say that now you're getting traction, you're getting ready to pitch this to get funding to our investors. So however, you look at the news and saw that a lot of websites were hacked. Tokopedia recently got hacked, Twitter just got hacked, and basically the investor told you, hey, I don't want any hacking, anything. I want your product to be secure, and which just makes sense, right? But I think the problem here is that you pitch this over the weekend and you need the more secure product in 2 days, and this is a very common in terms of like startup growth, right? And in order to accommodate this request from our investor, probably we came up with, hey, let's just start to add authentication and security to our website. So if you can see here, we added authentication to these 3 pages. You see there are 3 boxes marked authentication in each of the page. And because of the time constraint, we don't have time to centralize this, so we just copy pasted authentication logic in all these 3 pages. So after that, we were able to secure the funding. Now business was growing. We added a lot of more pages and we added a lot of more functionality to our website. Let's fast forward 2 months from now. After adding a lot of functionality and a lot of pages to our website, our website probably looks something like this. Again, I'm oversimplifying a lot of things, but let's say that we're adding 3 new pages. The first one is inventory, where it basically takes care of all the logic involving number of items you have in stock. The second one is reporting. Now that we're growing, we need to know how much profit we're making, how much revenue we're making. So we need this page to be able to accommodate this analysis. And let's say the last part that we add is recommendation engine. So if the user is logged in, instead of you showing the same list of products to everybody, you can recommend list of items based on your purchase history. And I think one thing that I wanted to double click on here is that we see a lot of redundancy, a lot of duplications in this architecture or in this logic. For example, you can see we have authentication logic built in every one of these pages. And if you look at a product list, now product list is product list logic displaying logic related to listing product exists in homepage, search page, reporting page, as well as recommendation page. And when you are in this position, now you basically got yourself a monolithic architecture. And these are some characteristics of a monolithic system. As I just mentioned in the earlier slide, there's a lot of redundant code, right? Basically, there's a lot of copy pasting that's happening. So a similar logic or exact same logic might exist in more than one place. And the second one is about adding new page. Requires a lot of refactoring and copy pasting. If you want to build a new page really quickly, we might see that, hey, we implemented something similar in this before. So let's say just try copy paste and edit a bit, or we can just copy paste directly and just do things on top of it. And the third point is that if you find that there's a bug in, let's say, using my previous example in displaying a product, we have to fix it in a lot of places. If we fix it in only one place, not everybody will get the same benefits. So you can have things that are broken in 2 pages, but it's working fine in 100 pages. So we have to make sure that we have to fix bugs in all of these places. And lastly, monolithic architecture is hard to scale. And what I mean by scaling is that we cannot target scaling per business logic. So to give you an example, let's say our homepage and our search page have traffic that are 20 times higher than the checkout page. So if we want to scale only these two functionality, only these two servers, we cannot do it because everything is only in one server. And also, as your organization grows and you have more and more developers, it makes it hard. Imagine you have 50 or 70 engineers working on one code base. There's going to be a lot of conflicts, merge conflicts. We have to make sure that there's going to be a lot of extra overhead to make sure that everybody changes merge correctly. Somebody's change is not overwritten by somebody else. So this is another complexity that is added by this as your company grows. But we can definitely do better than this, right? This problem must not be unique to our use case, and there's been a lot of success stories in our field, and there's been a lot of very smart people that are thinking about this. And the answer is yes. There's another approach of architecture called service-oriented architecture. It's also referred to as microservices architecture. So I'm probably going to use these terms interchangeably during this talk. And I'm going to explain very quickly in a very high level on microservices architecture. So instead of having one server that handles all the business logic, we separate this out to different services. To use our examples from earlier, let's say that we want to start with these 4 services to begin with. As I mentioned earlier, each service is its own server, and it is responsible for handling a specific logic relating to that domain or a specific business logic. For example, you can have a product service where the responsibility of this product service is anything related to product displays or product listing. We might have an auth service where the service will be responsible for anything relating to authenticating, making sure that our application is secure. We might also have payment service, and the service will be responsible for all money movement related logic. It can be any payments, any refund, all of that stuff will live in this payment service. And possibly we will also have inventory service to make sure that our inventory for our items are always accurate. So using this architecture to rewrite our system, how the homepage will look like in this new architecture. So instead of homepage implementing these logics inside, instead what will happen is that we will extract this logic out to different services. So the homepage in this case will work as the orchestrator, where you just talk to different services. So it will talk to product to get the list of product to display. It will talk to the auth service to make sure that our website is secure. And we will talk to search service to if there's any search functionality needed. And the job of the homepage here is much easier now, because instead of having to implement all these logics, it just calls these different services and just display the return value from the service to our users. And the other example I want to point out here is, let's say we want to add a new reporting page to our system. Let's say our reporting functionality doesn't exist yet. So what we might end up doing is to create a report service or reporting service where we basically the reporting service will host all the logic relating to reporting. So we will have to implement this report service. But for us to be able to reuse the listing of the product and the authentication, we can just call this product service and auth service. So it becomes very clear, right? It's much easier to separate logics. And these are some characteristics of a service-oriented architecture. The first one is that business logic for each area is located in one place. It's very insulated, which is nice. If you grow as an organization, you can have one team dedicated to one business logic. So probably you can have one team that is dedicated to product service. You can have one team dedicated to payment service, and that will help in developer velocity. And adding new page is much easier. As mentioned earlier, or as demonstrated earlier, it is much easier because we can more easily reuse the stuff that we built before by just calling these different services. We might still have to build a functionality that we haven't built yet, but we can more easily integrate the things that we've already built before. Only have to fix bug in one place. If you have any bug in your product list or in your product logic, instead of having to go to all these pages that implemented product logic, you can just go to this product service and just fix it in one place. Then everybody that is using product service will get the same benefits. At the same time, if you do have enhancement in your product logic, if you do have any performance enhancement, everybody will get the same benefit just by fixing it in one place. Lastly, it's having service-oriented architecture make it very easy to scale. And what I mean by scale is the targeted scaling, using the previous examples of if I just wanna if I just want to scale our homepage and our let's say if we just want to scale our search functionality, we can just scale our search servers instead of scaling the entire architecture or entire system. So now you might be wondering, if microservices architecture is so good, why don't everybody use it? Why is there still a lot of people who are using monolithic or any other architecture? And because just with anything, nothing is perfect, right? And everything comes with pros and cons. And these are some of the pitfalls of microservices architecture. So the first one is it's harder to maintain. You can imagine in our first example, in our monolithic application, we only have one server. But in this new microservice architecture, each service is basically its own server. And building a new service means that there's a new set of extra responsibility that you need to maintain. Sure that you now have a lot of technology, cloud technology, that makes it easier for us to maintain this, but the fact doesn't change, right? That we have a lot more stuff to maintain in this architecture. The second one is that it's very hard to define clear boundaries for each service. Again, I'm oversimplifying a lot of things here when I use the examples, but the key here is that sometimes you don't know what your business is going to evolve to. And at the same time, sometimes it's hard to define boundaries. For example, where should I put the logic relating to inventory in a product? Does it belong in product service? Does it belong in inventory service? I think you can make argument for both. And sometimes it's hard to define these clear boundaries. For some service, it might be as straightforward. For example, like auth service, every auth related activities goes to this service. But sometimes it's not as hard, especially if we have systems that are pretty complicated. The third point is that each service can have its own technology stack. So imagine you have 5 different services and you have 5 teams responsible for this different business logic. And each team can choose whatever they want. There's no rules stating them, hey, you have to use this programming language or technology stack. You can use Java for one service, you can use Golang for different service, or you can use Node.js. And this can be a problem as well. And lastly, communication is complex. When you have everything in one server, you can talk to each other very quickly. But then when you have services that are hosted in different servers, now you have to talk to different services. And this is not free. There is an overhead for communication. And it can be complex. We have different way of communicating. For example, we can use HTTP, we can use RPC, we can use different communication technology. But again, this is something that we have to take care of because we have to communicate between different services. So I just talked about the cons of service-oriented architecture. But what is if I want to now take a step back and, hey, I just want to do monolithic architecture. What is the benefit of the monolithic architecture? So the first one is that the monolithic system is usually simple to develop and deploy. You can imagine that everything, all the code is on the same code base, and all the code is deployed in one server. It makes it very simple to deploy, and any new developers that comes in can understand the system as holistically more easily. And yeah, it's much easier to maintain, right? Because again, the point I just mentioned that everything is one place, and it's much easier to just maintain one server compared to a lot of different servers. No communication overhead. This is by virtue of everything in one place. So we don't have to talk to different services. We don't have to make external calls. Everything is inside our control, and we don't need to talk to other services. Yeah, and I mentioned this a lot of times already, but everything in one place, which again can be a good thing, but can also be a bad thing. So now you might be thinking, hey, you're confusing me even more. So which architecture should I choose for my next project or for my company? And my answer is that there will be no perfect architecture. You can probably have the best system today, but it might not be the best system 6 months from now as the company or as the business grows. The tips is to know your use case and choose whatever fits your business need. Because in the end of the day, the system will evolve with your business. As your organization grows, or just as your business grows, the system will evolve with you. I'm also going to offer some guiding principles that might help you in making these decisions. And first off, the first point is to know your context, right? So if you're a small company, if you're a startup, this is probably the principles that you want to have, right? Like you need fast iteration because you might need to pivot. Something that you build now might not be viable for business. So it's very common in startup that it started as something but became something else, and this is the operating condition that startup is in, right? How do we make sure that we can be very quickly, we can be very agile, and we can pivot very quickly if needed. And if you're in this mode of operation, my advice here is on how to build system with minimal technical debt. Technical debt is inevitable, especially in the early stage, because here we're chasing proof of concept, we're chasing a product market fit, and we're gonna be doing a lot of hacks and workarounds. And the principle here is how to make sure that we minimize this. And in the context of bigger companies, everything is slightly different, right? We have a product market fit already, we have a running business, and our focus shifted from needing to be able to deliver stuff very quickly to more of these things, right? Like stability. How do we make sure that our website is up all the time? How do we make sure we have all the monitoring tools that we need to make sure that our website is up? We might now think about scalability as well. In the beginning, we might not need to care about this, but as we grow, we have to think about how we can scale as the traffic spikes. Let's say we might have a campaign where you are expected to have 10 times traffic to your website. How do you take care of that? And also, the last point I want to mention here is how do we make sure a lot of people can contribute productively, right? Being a bigger company doesn't mean that we can't be as productive as a startup, but how do we make sure we organize ourselves, how we organize our system so that we everybody is able to contribute very productively. Some tips for early stage startups. The first one is avoid analysis paralysis. And in general, just to keep it simple in the beginning, I've seen this happen where a lot of people are trying to find the perfect technology. trying to find the perfect system. Hey, I want to build this in the newest and the shiniest technology. I want to build this in whatever technology, the newest technology or the most stable technology, right? But I think the fact is, in the beginning, that is not your problem. Your problem is getting a product market fit and getting traction. And just choose whatever whatever you can be very productive, or whatever you want to learn, right? And just stick with it. Most of the technology that you choose, uh, be it programming language, be it data storage, caching technology, whatever that is, it will be good enough for a good while. I know there's a pretty successful big companies that are still using SQLite, for example, and that's fine. If you're at that point where you have to optimize a SQLite, then you're probably in a good state as a company, and you can allocate more resource to take care of that. And the second one is to do not over engineer stuff and just make it happen. Um, I mentioned this a couple of times already, but there is no perfect system, and the system will evolve with your organization, and there will be hacks and workarounds, and there is no way around it. The tips here is try to minimize these hacks and these workarounds. And if you do make this a trade-off, make this shortcuts, make sure that you document this, because you will thank yourself in the future. There's a lot of examples where there's some logic that nobody knows what this logic is doing. And sometimes the developers that created this code has left the company. So it's always a good idea to try to minimize and document these hacks if you do so. So yeah, thank you for attending my talk. This was pretty much the end of the content, and yeah, I'm wishing you guys good luck for the hack event. And if you guys have any question, I would be more than happy to answer them now. And, can somebody help me on? Okay, there is a question here. What are some ways to overcome complex communication when using the microservice architecture? So when using microservice architecture, overcome complex communication, I think my general strategy here is to make sure that we have a standard. It's about documentation and standardization, right? One is to make sure that each service has its contract, right? And that contract is, we can rely on that contract. So making sure that contract is being honored, and make sure that we give the clear contract, then it's one way to help in that. And at the same time, standardization in terms of technology. It's probably not the best idea if you, let's say, have one service that talks with HTTP API, one service that talks in XML, for example, and one service that talks in RPC, for example. I think it might be best if we can standardize all this RPC communication channel and having a clear documentation for each service. I think in my experience, that has helped a lot to have the standardization and documentation. Hope that answered your question. Is there any other question? I cannot see the YouTube comments, so yeah. Okay, how to decide whether to scale horizontally or vertically? So I think for the most part, you can only scale vertically to a certain point, right? I think it's pretty much going back to cost analysis, right? I think when you're starting out, you probably, let's say you're using a cloud technology, and let's say the price of the small or medium cloud servers in AWS is X, right? And probably if in the beginning, scaling to medium and large is pretty cheap, right? But then when you already start talking about from large to XL or different, then it becomes very, very expensive. So how to decide whether to scale horizontally or vertically is knowing where you are and predicting your growth. And it comes down to cost benefit analysis. Sometimes you can survive just by keep scaling vertically for the most part, and then you just scale horizontally when you need it. And again, there's no exact science on how to do it. It's kind of an art, right? And it comes with experience. But generally, usually for early stage, like even like a year or 2 years in, I think for the most part, unless you experience a very hyper growth, scaling vertically would be good enough in the beginning. What would be the best way to begin diving into web architecture? Any tips on how to get started? I think this is just not diving into web architecture specifically, but just begin diving into anything in general. Any tips on how to get started is just do it. There's a lot of just do some small projects, right? For example, you can make a simple app, a clone of your favorite apps. Let's say you can make a clone of Twitter, you can make a clone of Facebook, and you just do it. And by doing this, right, by actually doing stuff, you can have a lot of experience. You can gather insights from these projects, and it doesn't have to be perfect. Right? Take this as a learning opportunity on how you can grow. And yeah, I think my advice would be just to do some of this, to do some side projects. There's a lot of resource out there. There's a lot of Udemy resources, a lot of free YouTube resource on how you build some projects, and just find something that you're passionate about and just try doing it. I bet you will learn a lot more doing these projects than just learning by the books. How many microservices are there in OVO, and what's an appropriate timeout value between communication of microservices? I doubt we would want to keep a connection open for so long. How many microservices I think in OVO there, each team has its own microservices. If I have to guess, probably in total, OVO will have around 40 or 50 microservices. What's an appropriate timeout value between communication of microservices? And it actually it depends. It depends, right? So it depends on your use cases. For example, our payment service that handles money movement. The service will have a very, very strict timeout SLA. I think it's in the realm of like 20-30 milliseconds, because this is needed, right? Like you don't want people to like hit our API and then wait for like 2 minutes. It's not acceptable. But for some other use cases, this might not be the case. For example, we have our lending business where we try to underwrite, or we try to take an application, take an applicant and see how risky this person is, and if we should give them the loans. And in this service, it's very different, right? Because the service would need to talk to different credit bureaus. We have to talk to different external parties. And in this case, we have a timeout that is 10 milliseconds is just not feasible in this use case. So I think it depends on the use case. And yeah, in general, we don't want to keep connection open for so long. But I think in general case, probably something I think the maximum would be like 200 milliseconds or something along those lines. Next question. Can we actually put the services still in one server in form of monolithic architecture, but kind of having several microservices? Yes, we can actually do that. We actually kind of did that at Eventbrite. So what we ended up doing is that we have different business logics in different services, but it's kind of still in the same server ecosystem. And I think the problem here is that I think our problem when we're doing this is not in the logic itself, but it's actually in the database, because we still talk to some one master database, and this database are being used by so many different logics, and this becomes the bottleneck. So yeah, I think one thing that I want to key in here is that what I explained earlier is very simple, very simplistic view of things, and there is a lot of variation. There's not black and white, right? There's going to be a combination of microservice. There's going to be a combination of monolithic architecture. It's going to be a combination of everything, and the key here is to get back to the basic, right? What is your use case, and how is this helping you solve that problem? Because everything, if you any technical decision that you make will have some implications, and the challenges will be unique to you depending on what you choose. Yeah, I hope that answered the last question. Yeah, I think that's it for me.
All right, thank you, Mr. Herbert, for your insightful talk. I'm sure our participants really enjoyed it and learned a lot. And
All right.
so we will be taking a brief intermission for around 10 minutes where we will have a panel by Blibli. So stick around.